So first, called Bayesian theory. Bayesian theory is where we begin. So there is question 1 that reads that consider 3 identical bags A, B, C. Bag A contains 2 gold coins, bag B contains 2 silver coins, and bag C contains 1 silver and 1 gold. What is the probability of selecting bag A out of 3 bags? So as you remember, we said that probability is equal to desired over the possible. So what we desire here is so the probability of getting A, you can first of all look at it this way. We desire to get A. And the possible is that there is bag A, there is bag B, and there is bag C. Those are the possibles. So if you convert this now to numbers, then you will tell us this is 1 out of 3. That is the probability of selecting bag A out of the 3. And the same case would apply to bag B as well as bag C. What is the probability of selecting a gold coin from bag A? Now, when you're dealing with these questions on Bayesian rule, is advisable you start where the question has ended. So if you look at the question, it has ended at bag A. So you start with A this way. Given, I told you that Kasibo represents given. So given, if you go backwards, you find gold. So given gold. Now this one opens up as probability of gold and A, you divide by probability of gold. That is how at the basic level it opens up. But you can further now open this. You can open it further this way. So this one is probability of, naona hapa venye iko inapinduka the other way around. So now you start with G, given A, you multiply by probability of A. Then for this G, it is G in A, getting a gold coin in bag A, multiplied by probability of A, plus probability of gold in B, multiplied by probability of B, plus probability of gold in C, multiplied by probability of C. So this is how you go about it. If you look at bag A, it has 2 gold coins. So to get a gold in A, it is then 2 out of 2. And to get bag A is a third. The same case applies here, 2 out of 2. Then if you look at bag B, it has no gold coin. So to get a coin there that is gold, it is 0 out of the 2 coins which are there. And the probability of getting bag B is a third. If you look at bag C, it has 1 gold coin and 1 silver. So to get a gold is 1 out of 2. And the probability of getting C is a third. Okay, you will finish at that. Let us go to question 2. Question 2, it says when a machine is set correctly, it produces 25% defectives, otherwise it produces 60% defectives. The chance that the machine is set correctly is 50%. The machine was set and before commencement of production, one piece was inspected and found to be defective. What is the probability that the machine was set up correctly? So we can argue this. Probability, I've told you, you begin where the question has ended. So it has ended set correctly. Given, you start going backwards. Going backwards, you find that the item was defective. So given defective. And this one will open as probability of defective and set correctly. You divide by the probability of defective. You divide by the probability of defective. And this is the one that I've told you further opens up. Further opens up as probability of getting a defect given that, given that we are set correctly, multiplied by the probability that we are set correctly. Probability that we are set correctly. You divide by the probability that we can get a defect, given that we are set correctly, multiplied by the probability that we are set correctly, or it is possible to get a defect when we are not set correctly. So probability of getting a defect when we are not set correctly, you multiply by the probability that we are not set correctly. The probability that we are not set correctly. So looking at the question, we find that the probability that the machine, when the machine is set correctly, it produces 25% defectives. So that is the probability of getting a defect when you are set correctly, and 60 when not set correctly. And the probability that the machine is set correctly is 50%. So this then changes to something like this. So when we are not set correctly, it's 0.6 and 0.5 there. So solve that. And then on your own, I suggest you attempt question 3. Okay. You are through, eh? With that one, with the other one, number 3. Eh? Not yet, but at least you have written something this. Probability of getting X given defective. It is probability of defective given X multiplied by probability of X. All these divide by probability of a defect given X multiplied by probability of X plus probability of a defect given Z, not given Y, or because I've already written and we write. That's my zinafuatana. That is Z and plus probability of defect given Y multiplied by probability of Y. Multiplied by probability of Y. So if you look at those that are produced by X, they have a chance of 2% of being defective. And X is producing 50% of all the items. So this will be 0.02 times 0.5. Plus those that are made by Z, they have a 3% chance. And Z is making 20%. Plus those that are made by Y, they have 0.02%. And there is 0.3. Sasa hiyo utapambana nayo baadaye. You will do the same, look here. You do the same thing for Y. Sasa hapa ikuwe Y. Then you do the same thing for Z. Because the question is saying X or Y or Z. Sasa ukishafanya for each, you add them. And when you add them, the answer should be 1. Because you have covered everything. You have done X, Y, Z. Now, in your past papers, you can attempt. I think I came with the wrong past paper. Your past Papers. It's talking about cars. Page 48. Given up. 48. Question? Is that question 5? Yeah, the following data. Kama pages are different. Hiyo ya two taxes Hebu nisome ni ya mwaka gani? Soma ni ya mwaka gani? Because the year of the exam. May 2014, question 5A. Hiyo inaongea mambo ya taxi grey and blue. Yes. Umesema ni May 2014, question 5A. Yeah, so you attempt that. To be good. So that is Bayesian rule, and Bayesian rule can also be handled using a tree, a probability tree. It can also be handled using a contingency table. But after we have gone through those, that's when maybe you'll be able to see that. So let's now look at what we call a contingency table. A contingency table is simply an arrangement maybe we can write very brief notes about that. A very brief statement or notes. And we write that this is a tabular presentation. This is a tabular presentation of two experiments. And their events and probabilities. The values in the cells, represent intersection. Presents intersection and are therefore described by the word add. Therefore described by the word add. And analyzed using multiplication rule. Analyzed using multiplication rule. So the totals of the rows and columns, represent union of sets. Union of sets described by the word all. Described by the word all. And analyzed using addition rule. And analyzed using addition rule. So, the table can also be used to deal with Bayesian rule. The table can also be used to deal with Bayesian rule. Good. So let's look at this question. That is number 4. In a certain factory which employs 500 men, 2% of all employees have a minor accident in a given year. Of these, 30% had safety instructions, whereas 80% of all employees have no safety instructions required. Find the probability of an employee being accident-free, given that he had no safety instructions, and number 2 had safety instructions. Now, when you read a question like that, the very first thing is to know how you can classify the question into two experiments, so that you are able to draw it in form of a table. Now, in this case, we have two issues at hand. We have two issues at hand. What do you think they are? We are told to describe that. We are told to describe into two, or to divide it into two. What would you say? Because you must be able to divide into two so that we have what we are calling the rows and the columns. What we are calling the rows and columns. Now the question is about two things. One is about the accidents. There are those fellows who had minor accidents. I want us to call them A. There are those who are free of accidents. And I want us to call them B. Then obviously now we will have what? Total. Then there are those who have instructions, or there is the issue of the instructions, the safety instructions. So there are those who have been given the instructions. I want us to call them C. And we had those who had not been given, or had not been given. I want us to call them D, so that we have the total here. Now the question says that all the persons, they were what? 500. And then we are told of 2% of all the employees had minor accident. So those who had the minor, their total is 2%. So you get 2% of 500. Tell me what that is. It is 10. That therefore tells you that those who are free of accident must then be 500 less 10. That is 400 what? 90. The question further says that 30% of those who had accidents, 30% had safety instructions. So of these, 30% had been given the instructions. So if you are to take 0.3 of 10, that will give you how many? 3. It then follows that those who had accidents and did not be given instructions must have been 10 less 3. So those are what? 7. The other instructions we are told is that 80% had no safety instructions. So those who had not been given, there were 80%. So 80% of 500, that is 400. So that's what we are told, that 80% of all employees have no safety instructions. So those are the ones that have not been given. It then means that this one should be 500 less 400, and that gives us what? 100. Which further follows that this then should be 100 less 3. We get 97. And this one should be 400 you less 7, which gives you 393. So the goodness of that table so that we can now do some workings from there. So we are through with that. So let's now start working some figures. If we are told to tell us probability of A, using the formula that we know, that you get the desire, you divide by the possible. A, you see there are 10 of them. And all the possible, they are what? Yeah, as simple as that. You can leave it that way. You choose to simplify, no harm. Similarly, if you are told to give us probability of D, you are told to give us probability of D, you will go to where there is D. D, all of them, they are what? 400. You divide by what? 500. If they told you to give us probability of B and C, probability of B and C, you go to where they meet. This is what to need to make an intersection. An intersection is cells, whatever is inside. So B and C, where they meet, we have 97. You divide by 500. 97 divided by 500. If you are told to tell us probability of A and D, probability of A and D, you go to where A and D meets, and that is 7. You divide by the grad of 500. If you are told to give us probability of A given C, A given C, this one, you don't open the formula like you are doing in the other case, because it's Bayesian now, right? But it's simple like this. Where you are told given, given means it has already happened. So unakimbia hapa kwa C. So C here. Ukiwa kwa C, unatafuta A. So when we are in C, A is this, you know? And the whole of C is what? That's it. If you are told probability of B given C, you give us probability of B when you are given C. You simply run to where there is C and you look for B. It is 97 out of 100. So now tell me probability of D given B and probability of C given A. D given B, you have written 393 out of 490. C given A, you have written 3 out of 10. Good. The next one that you can be told to do is If they tell you to say probability of A or B. Now this one, I want to open it. It opens up as probability of A plus probability of B minus probability of A and B minus probability of A and B. So for A, I think you know those things now. So hii umesema probability of A umesema 10 out of 500, okay? Na hii ingine ukasema 490 out of 500. Na hii ukasema 0 out of 500. That's it is 0 because unaona hakuna mahali A and B watapatana. Yes. Similarly, if I were to tell you to give me probability of B or C, it will be probability of B plus probability of C minus probability of B and C. Probability of B and C. So this becomes probability of B is 490 out of 500 plus probability of C is 100 out of 500 minus kuna mahali B and C wanapatana. B and C wanapatana hapa kuna 97. Yes. 97 out of 500. So you just leave it that way. Now, when we looked at set theory, I told you an element can only appear once. If you look at this 490 here, the 490 is made up of 97 and 393. So this 100 is made up of 3 and 97. This and this. So if you were to put it this way, remember this is the unit because of the class. Then you can see 97 is appearing twice. And we said no member should appear twice. That's why now this one must be removed. So similarly now, can you give me probability of A or D? And just write the answer straight. Probability of A or D. Umeandika probability of A or B, A or D, umesema 10 out of 500, okay? Plus 400 out of 500 minus 7 out of, yes. So now we can give the solution. So andika solution. Solution sasa nataka tujibu what the examiner had asked in that question, because we were first of all doing the illustrations. So the examiner here alikuwa ameuliza find the probability of an employee being accident free given that he had no safety instructions. So Roman 1, it is probability that given. So someone was what? Accident free. Accident free ni huyu B. B. So B, given that they had no safety instructions. So no safety instructions is D. So sasa hiyo unakimbia where there is D. D is 400. Ukiwa hapo utafute B. B is 393. So the answer is 393 out of 400. And Roman 2, the probability that this guy was accident free but had safety instructions. So that is probability of B given he had safety instructions C. And these ones are what? Ukiwa kwa C, after B, that is 97 out of 100. That's how we deal with contingency tables. So on your own, I would like you to handle question question 5. Question 5. And then you also handle this one of April 2022. Question 1C. April 2022, question 1C. I think I should have another one that has a contingency table in the past papers. Page 58 is one of June 2013. June 2013. Question 2C. June 2013, question 2C. Okay. Let's now look at probability trees. The probability tree. Probability tree. Probability tree, right? That a probability tree is a diagrammatic presentation. A probability tree is a diagrammatic presentation of experiments, showing the outcomes and probabilities. Showing the outcomes and probabilities. It is usually drawn from left to right. It's usually drawn from left to right. First of all, experiments do not share starting points. Experiments do not share starting points. Another point. Events that share starting points. Events that share starting points are mutually exclusive. and their probabilities should add to 1. And their probabilities should add to 1. So, events along the tree, that is left to right, are intersections, while top-bottom events are unions, Okay, so let's look at question 6. We are told in the past, 2 building contractors, A and B, have competed for 20 building contracts, of which 10 were added to A and 6 awarded to B. The remaining 4 contracts were not awarded to either A or B. 3 contracts for buildings of the kind in which they both specialize have been offered for tender. Assuming that the market has not changed, find the probability of all those. Now, in this question, we are dealing with 3 contracts. Contract A, B, or contract 1, 2, and 3. And those are the experiments. They are the experiments. And we have said experiments do not share starting points. So, what will happen is that we have the first contract here. And this first contract, it will either go to A or B, or none of them will get it. That's the first contract. Now, these are mutually exclusive events. They are sharing a starting point. By mutual exclusiveness, I mean, if A gets, then B cannot get. And it cannot be that no one has gotten because A has gotten. Yeah. Then now you bring the second experiment. The second experiment will also be the same thing. That's the second one. Then you bring the third one. And the same case applies here. So how you go about it, you count, these are 1, 2, 3. So 3 times 3, that is 9. 3 times 3 is 9. And those 9, they have come from one branch here. And we still have 2 others. So that means we multiply by 3, and that means we are going to have 27 tails. So this one is called a sketch. It's the one that guides in the drawing of the tree. So you go to a fresh page and you estimate where your tree will get to. Now mine will get up to here. Judge where it's getting up to. Utapanga 27 tails. Let's do that. You look at up to where itafika, because we are supposed to start from the past, going backwards. So upange 27. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So if there are 27, how life is. It's complicated. So that is the first contract. I can go to A, B, or none. And go, the second one can go to A, B, or none. A, B, or none. A, B, or no one. The same case here, A, B, or none. If I do A here, alafu tunaambiwa A has gotten 10 of them, 10 out of 20. So that means his probability is 0.5. While B amekuwa akipata 6 in 20. So that is 0.3. Na huyu mwingine anapata 4 are not awarded. So that must be 0.2. So you assign those probabilities that way. We are finished, eh? So sasa ukiulizwa probability that A will obtain all the three. Probability that A will obtain all the three, it is A getting first, A gets the second, and A gets the third. So unafuata, tumesema when you are going along the tree, that is intersection. So they become multiplications. So A is 0.5. Getting A here, 0.5, and getting A here, 0.5. That's one. What has guided us about this tree? Because we were dealing with 3 contracts. So hii ni contract ya kwanza. Hii ni ya pili. Hii ni ya tatu. So tumeambiwa 3 contracts of whatever are on offer. 3 contracts of the kind they have been offered. So tunaangalia mtu atapata ngapi kwa hizo 3 zimekuwa floated. The other one is probability that B gets at least one contract. So probability of B gets at least one, you can see B almost kila mahali. There are many, when you're told at least one, kumaanisha amepata moja, mabili ya matatu. Yeah, at least means that value or more. So it will be easier. We work with where he has nothing, then we subtract it from one, where he has nothing. So probability that B gets none. B gets none. Tafuata hivi. Naona hii hakuna hii hapa. So this is probability of A. Haya, hapa B hakuna kitu, hapa hakuna. So this is probability of A, N. Haya, tukikuja hapa hizi tatu B hakuna kitu. Tukikuja hii hana, so it is the probability of A, N, A. Haya, tukikuja kwa huyu hakuna, so it is A, N, N. Haya, hizi zote B hakuna kitu, hizi mpaka hapa. Lakini tukifika hapa hana, it is N, E, hapa hako nayo, hapa hakuna, so it is N, N. Hapa hizi tatu B hako nayo, hii hakuna, so it is N, E, na hii ya mwisho N, N. It's easier that way. Otherwise, hizo zingine zote zimebaki, B yako na kitu So kama unataka kuenda straight, then uchukue hizo zingine zote you add. That would be a lot of work. But these ones you can see they are 1, 2, 3, 4, 5, 6, 7, 8. So tumebakisha 19. Remember there were 27. So sasa hapa ni kujaza tu hizi. This is 0.5 times 0.5 times 0.5. This is 0.5 times 0.5 times 0.2. 0.5 times 0.2 times 0.5. 0.5 times 0.2 times 0.2. This is 0.2 times 0.5 times 0.5. This is 0.2 times 0.5 times 0.2. This is 0.2 times 0.2 times 0.5. This is 0.2 times 0.2 times 0.2. So that now down there we put your probability that B gets at least one. At least one, it is the same thing as 1 minus probability that B gets none. B gets none. So tasema 1 minus ile total utakuwa umepata hapo. Do this for the interest of time. Wacha hizi yani. So ukope hii. Simeelewa tunafanya hivyo. At least niache nimekudesignia hii nyingine ya part C. Because we leave it incomplete. So tutaweza kulimaliza because next time tuweze chora ile waste of time. Hiyo ingine probability that two contracts, or probability that what? One contract is awarded, will not be. Yeah. Two contracts will not be awarded. So if two will not be awarded, only one will be awarded. Sindio? Only one. Sasa, assuming the first contract awarded. So if it's the first, it will be awarded to A, the second to none, and the third to none. Or here ya kwanza, it can also be awarded to B, because here lazima ati atapata. Hiyo ni the first one, Haya, to assume sasa contract 2 ndio imepeanwa. So that means 1 was not given, 2 was given to A, that was not given. The first was not given, second was given to B, that was not. Then assume it is the third contract that was given. So the first not given, the second not, but the third goes to A, and the same case here, but now it goes to B. So that is the probability that two contracts will not be awarded. So utajaza hizo. Then finally, A will be awarded first contract, B second, and A the third. Hiyo ni kumaanisha probability that A gets the first, B the second, and A the third. That one is as simple as that. 0.5 times 0.3 times 0.5. So we can call it at that point. Then when we meet next, we shall seek to do one more. So, thank you.